Let's consider a car merging into freeway traffic on an on-ramp. We're going to draw a little diagram here to help us out. Say that our initial velocity is 10 meters per second. So I've got initial velocity of 10 meters per second. We accelerate at 2 meters per second squared. So we write that down. And we want to know how long it takes us to travel the 200 meters up the ramp. So we're traveling 200 meters. So how long? What we're trying to find here is we're trying to find time. That's what we're trying to find. So if I'm trying to find time, I can look at my constant acceleration equations and say that, hey, it's accelerating at a single value. That's a constant value. So we'll use our constant acceleration. And we'll see if we can find an equation that can have any of the things we know, and hopefully only the thing that we don't know as the one unknown. So looking through, there is an equation that looks like it might work, and there might be a little bit of some algebra we have to do to solve it, but it should work out okay. So my final position is initial position plus initial velocity times time plus 1/2 acceleration times time squared. We can now look at this and say, I know all of these things. I know final position, initial velocity, and acceleration. And the thing that I don't know is time, but it appears twice in there. So we're going to have to do probably a quadratic to solve this in the general case. You could also do completing the squares or however you want to solve this. You could do a numerical solution, plug it in and find the zeros. However you want to solve this works out fine. I'm going to show you using the quadratic formula. To make our lives easier, we're going to plug in numbers. A lot of times I'll do algebra first and then only plug in numbers at the end. But here I'm going to plug in numbers to make the quadratic relationship more clear. So 200 meters is equal to, let's see, we start at position 0. We start not from rest, but we start with some initial velocity of 10 meters per second. If we started from rest, then we could just take a square root, but we don't. So this is times time. And then plus 1/2, my acceleration was 2 meters per second squared times time squared. So we'll simplify this and try and move everything to be on the same side. And we'll write this without units, again, just to try and make the math a little bit more clear. So this, we get 0 on the left. And then we'll write this with the t squared term first. So 2 times 1/2 gives us 1, or just t squared. We have 10t. And then when we subtract 200 from both sides to move the 200 from the left to the right, we end up with minus 200. So that's one equation, one unknown. We solve this, and I'm going to show you solving this with the quadratic formula. So in general, when you have, let's say, at squared plus bt plus c equaling 0, you have a solution to this that's given by negative b plus or minus the square root of b squared minus 4ac over 2a. And you can derive this yourself by solving this in the general case by trying to factor stuff out, and feel free to do that, but we're just going to start with this formula. So in our situation here, my a value is just whatever the coefficient here is, which when there's nothing by it is 1. So we end up with a equals 1, b is 10, and c is negative 200. And we plug those in. So we say my time is equal to negative 10 plus or minus the square root of 10 squared. So this is b squared minus 4 times a of 1 times c of negative 200. So that negative times negative gives you a positive inside there. And then all divided by twice a, or 1. When you evaluate this, you evaluate it once with the plus on top, and then once with the minus. And at the end, what you end up with is you end up with two values. You say that my time is equal to either 10 seconds, or it's equal to negative 20 seconds. Those are the two answers you get from this. So which one is correct? Well, Maybe you want to say both. That can't be true. It can't take both amounts of time. Here, you look at how we set up our physical situation, and you see what makes physical sense. Here, it doesn't make sense that you go backwards in time and 20 seconds in the past, we were at the top of the ramp. That's not what's going on here. This is just an artifact of the math. We need to look back at the physical reasoning and say, okay, we start from time equals 0, and we're really only considering times greater than 0 here, because we're marching forward from time equals 0. So the actual answer here would be it takes 10 seconds to get to the top of the ramp, assuming that that's our acceleration.